Hello students, I am starting a new topic chapter 10 wave optics, and teaching hours for this topic is 9, and marks allotted is 9 to 10. Under this topic, in the part 1 I am explaining wave models, and in the next video I am explaining wave front and its types and also Huygens principle. So in the wave model I am explaining some important wave models, and after that wavefront. There are three types of wavefront. I am explaining it. After completing the concept of wavefront, I am explaining Huygens principle. Let us start with the corpuscle model. It started in the 16th century, and corpuscle means light elastic particle. If you take one candle, if I treat it as a light source, surrounding that light source, if you treat these yellow dots as light elastic particles, then these light elastic particles are the uh, sources of light. I mean, light is emitting in all direction in the form of these light elastic particles or corpuscles. And under this concept, corpuscular model of light, Snell's law was derived successfully, and also the law of reflection and refraction also explained properly. If you take reflection phenomena according to this corpuscular model of light, whenever light elastic particle hits the reflecting surface and these light elastic particles bounce back or repel from the reflecting surface, and they called this phenomena as reflection. And you can see this normal perpendicular to the reflecting surface, the angle made by the direction of the incident light is equals to the angle made by the reflected light with normal. So it fulfilled the law of reflection. And also they have explained refraction also. When light is in the form of these corpuscles, whenever it is entering from rarer medium into the denser medium, the direction of corpuscles changes in the denser medium. Whenever, according to this corpuscular model of light, whenever this direction of corpuscles in the denser medium bends towards the normal, then speed increases. This is according to the, or this is a prediction made in the corpuscular model. But later on, they conclude that whenever light is entering into the denser medium, the speed of light decreases. So this is what contrary statement or prediction made in the corpuscular model of light. That is why corpuscular model fails to explain why the speed of light greater in the denser medium. Now coming to the second model, Newton's corpuscular model. Under this model, Newton has modified the predictions or the theory developed in the corpuscular model of light. In those days, people were not readily accepted the predictions made in the corpuscular model of light. That might be the reason Newton took this model and he improvised it. And according to this Newton's corpuscular model, he agreed almost all points, almost all predictions made in the corpuscular model of light. But only thing is, he has written all these details, predictions and theory in the book titled Optics, Opticks. And this book was so popular in those days. And if you see this picture here, these elastic particles, they are hitting the refracting surface and changing the direction when it enters into the second medium. But only drawback of this Newton corpuscular model of light was he also uh, agreed to the point that when light is entering into the denser medium, speed increases. And also the most important thing is the Newton corpuscular model fails to explain the simultaneous phenomena of reflection and refraction. For example, if this is a surface, this surface is partially reflecting and partially refracting surface. Suppose if light in the form of these elastic particles hits the surface, a part of light is absorbed and enter into the denser medium, and the remaining part of light is reflected back into the same medium. So this is called a simultaneous process of reflection and refraction. But according to Newton's corpuscular model of light, when light is hitting the surface, so almost entire amount of light is repelled from the surface. But here a part of light is repelled or bounced back, reflected, and the remaining part of light is refracted into the denser medium. So he couldn't explain the simultaneous phenomena of reflection and refraction. That is why Newton's corpuscular model of light failed. Now let us start with a question: what is wave? Because this is a very important question. It is required to explain the remaining concept in the topic. The whole topic is depends on to what extent you are going to understand the concept of wave. First of all, what is wave? You must understand what is wave, the concept of wave. So wave can be described as a disturbance that travel through the surface of water or surface of any medium. Say for example, if you drop a stone on the surface of water, you can observe the ripple or the water waves surrounding that the point of disturbance. So I show you one water wave simulation. Here, initially the surface of water is still, there is no disturbance at all. Once I disturb the surface of water, you can observe here water waves generates. See this one, how these water waves are generating from the point of disturbance. So these water waves is the imagination or the visualization of these water waves is very very important to understand the concept of wave. I can show you one more picture here. You can see the water waves. This is the upper portion, here down, up, down, up, down. In this way, water is moving, or the waves are traveling in one particular direction. And if I represent this upper portion of wave by this upper portion by this type of curve, and if I represent the lower portion of this wave here, this is the upper portion and this one is the lower portion. This lower portion, if I represent it by this symbol, so this completes one water wave. You can represent, suppose if I take the source of disturbance, and if I take this upper portion as a thick line, thick circle, and the lower portion as dotted circle. So this is nothing but water wave. You can observe here how the water waves are generated. See this one, water waves are generating just like this, just like a concentric circles. So you can represent water wave either in this form or in this form. So this visualization of wave is very important, because I am going to correlate this concept of wave with light. So my assumption is, I mean, my idea is, I want to connect the imagination or visualization of this wave to the light. So my point is, light also travels in the form of wave, just like water wave. So this is what I wanted to convince. So if you make assumption like this, water is spreading in all directions in the form of concentric circles, or in the form of up and down. One time the wave is moving upward, another time the wave is moving downward. So you can represent water wave like this, or you can represent water wave by thick and dotted circles. So in the same way, I can represent a light which can spread the waves in the form of these circles or in the form of a wave, so that it will be easy for me to convince you uh, Huygens principle and the reflection and refraction phenomena based on Huygens principle. Now let us move to Huygens principle. In the Huygens principle, it again started in the 16th century by Christian physicist Huygen. He developed the theory and he convinced the people that the light is traveling in the form of wave, and he discussed all those important assumptions and predictions in his theory, and we are using the principles of Huygens theory in the concept like refraction and reflection in this topic. And another wave theory is Young's wave theory of light. In the Young's wave theory of light, he also made the same prediction that light is traveling in the form of wave, and he also shown that the interference phenomena, how interference take place and how wave concept can be used to understand the interference phenomena. So it developed in the 18th century. But the interesting point is Young, it took almost 40 years to convince the people that light is traveling in the form of wave. That might be the reason that Newton was so popular in those days, and people were not readily accepted the predictions made by either Huygen or Young. Young really he took 40 years to convince. He made a lot of hard work to establish his wave theory. Now coming to the last one, which is uh, Maxwell's electromagnetic theory. The problem of wave theory was uh, they predicted that light is traveling in the form of wave and it requires intervening medium. So they thought that there is a ether medium, hypothetical ether medium was there always, and light is propagating in the form of wave. But they couldn't explain why light is traveling in the vacuum, how it can travel, how it can propagate in the vacuum. In the vacuum there is no medium, but without intervening medium how can a wave can travel? But Maxwell he successfully explained this concept. According to Maxwell, light is nothing but electromagnetic radiation. Electromagnetic radiation means he has combined two important theories. One is electricity, another one is magnetism. And if you take this particular diagram here, the blue line indicating, assume that blue line are indicating electric vibrations and these red lines are indicating magnetic vibrations. As these electric vibrations changing with respect to time, so simultaneously magnetic vibrations were produced. As these magnetic vibrations changes with respect to time and electric vibrations simultaneously produced. So in this way, electric vibrations and magnetic vibrations, they are perpendicular to each other and they are complementing to each other. Whenever the time varying electric vibrations produced and simultaneously magnetic vibrations were produced, as time varying magnetic vibrations produced simultaneously electric vibrations produced. So in this way these electric vibrations and magnetic vibrations, they are producing simultaneously, they are mutually perpendicular and they are perpendicular to the direction of the propagation. So this is the reason why light can travel in the vacuum without any intervening medium. And he combined, the very interesting part is unification. He combined electric concept, electricity, the laws of electricity and the laws of magnetism. He combined both together and he called it as electromagnetic theory. And light is nothing but electromagnetic wave. This is how he predicted the existence of electromagnetic wave. Now in this topic, so I'm showing one simple diagram here. There are two bulbs. You can treat it as a source of light. This first bulb is emitting the light in the form of particles. That is the reason I have shown it in the form of dots. In the second diagram, this bulb, you have to make some assumption. Then only you can understand the theory of interference and diffraction. So second bulb, if you treat it as a source of light which is emitting in the form of waves. Now what happens? What happens if I hold a barrier in the path of light, which is this first bulb, which is emitting the light in the form of a particle. If I hold a barrier, an obstacle in the path of light, what happens in this region? There might be a shadow. So shadow is expected and shadow produced whenever a barrier held in the path of light, because light is traveling in a straight line direction. So when you held the barrier, this part of area is blocked by this barrier, and in this area light is not entering, and that is the reason a shadow is produced. Then if you take a second example here, light is emitting in the form of waves, and here the waves are now, again if you hold the barrier in the path of light, the now waves are bending, the light is bending at the obstacle, at the edges of the barrier, and entering the region where you are expecting shadow. In this area you are expecting shadow, but some amount of light is entering in this region. This is an important property, and this important property we are studying in the topic waves optics. So especially in interference and diffraction, so we are using this important property. So whenever you hold the barrier, the light is bending, the light is changing its direction, it is entering into the region where shadow is expected. Now coming to this important chart, because I'm taking some examples here. Light property I'm taking, and if you leaving this first property, pressure, it is not required for present discussion. If you take the remaining property, reflection, refraction, diffraction, interference, and photoelectric effect. So how these properties can be explained using particle theory and wave theory? This is a very interesting part. And if you take reflection and refraction, if you take only reflection, you can explain this property, reflection property, by particle theory and wave theory without any problem. Then if you take a refraction property, you can explain using particle theory, but not to the satisfactory level. But you can explain the refraction phenomena using the wave theory. That means if you treat light as a wave and if you treat light as a particle, in both cases you can explain reflection and refraction. There will be no problem. But if you treat light as a particle, then you can't explain the diffraction and interference phenomena. Diffraction and interference property can be explained successfully, satisfactorily only when you treat light as a wave. Suppose if you take a diffraction phenomena is a bending of light. Bending of light at the obstacle, at the corners of the obstacle is a diffraction phenomena. And the modification of light is a interference phenomena. So both important properties you can explain it only by wave theory. You can't explain both property by particle theory. And if you take a photoelectric effect can be explained only when you treat light as a particle. I mean, the particle theory can explain this photoelectric effect satisfactorily. You can't explain photoelectric effect using wave theory. So this is the difference between particle theory and wave theory. So both theory are important. Particle theory is useful to explain some important property, and wave theory is also useful to explain the remaining property. Though wave theory has failed in certain area, but wave theory is one wonderful theory for explanation of diffraction and interference phenomena.